Probably the biggest experiment here at the Smart Home has been the heating and cooling system. There is a ton going on, so let's dig in. We started with a passive design with double stud walls and a layout that minimizes the solar gains in summer, but allows for free heat in the winter. But that meant a little bit too much free heat, especially in the spring, when the exterior of our south walls gets pretty hot. According to our data, a better design would use a more reflective exterior paint and maybe increase the venting on the backside of the cladding. But everybody loves how quiet the house is because of those thick walls and the triple pane windows. Our 3-mode heat pump has worked perfectly, and the data shows it's performing exactly according to the manufacturer's specs. One of my favorite features is that when we're cooling the house, when we pull that heat out, the heat pump can push that energy straight into the hot water tank instead of just dumping it outside. One of the big questions was whether our radiant cooling system would be up to the task during the hot summers here in Davis, California. We knew that the system would have long time delays and somewhat limited capacity, but combined with our nighttime pre-cooling, the system could usually keep up. On really hot days though, we saw rapid rises in indoor air temperature, and some people found the slab to be uncomfortably cold underfoot. The radiant heating in the winter feels great, but we just weren't satisfied with the cooling performance. Perhaps the most experimental piece was how our geothermal heat pump exchanges heat with the earth using these shallow boreholes, only 20 feet deep, but with 250 feet of tubing inside. We wanted to test if this design could provide enough capacity for the house. We actually tried 2 different types, one dry and one wetted with gray water, and they both worked pretty well. The wetted geometry gave us some trouble with leaks, but the simple dry borehole design is definitely a winner. Heating, cooling, and hot water are some of the biggest energy loads in a home, and managing them is critical to achieving a zero net energy future. As with all of our systems, please explore the website, look at the data, read the reports. We hope that our Living Lab helps you create better homes in the future.